Today I want to talk to you about 3 different research projects that I've been involved with over the years, and what is true to all of these projects is that they're all about sustainability and delivering sustainable agricultural practices. And so today we've actually heard about why that is important, especially with regards to ammonia emissions, but I'm actually going to go on and talk about methane emissions as well today. Why do we need sustainable agricultural practices? Well, one of the main drivers for this kind of research is the fact that we have lost a lot of our farmland biodiversity. And this has resulted as a consequence of the introduction of the Common Agricultural Policy, which really took effect in the 1960s, leading to mass production and at the expense of our farmland biodiversity. One of the key indicators of that loss has been that of the farmland birds, which are also used as a quality of life indicator. So it's therefore a bit concerning that we've seen significant declines in our farmland birds over the years, especially from the 1970s onwards. And this is data which has been recorded by the BTO and the RSPB consistently over that period. If we're to be looking at getting back to sustainable practices, we need to think what has caused that decline. And it is, of course, the loss of habitat. And so we need to be able to rebuild our landscape with regards to what's going on with floral resources. If we can get that part right, then we can lead on to benefits for those higher trophic levels. So we've got the insects that the birds need, as well as the food resources in terms of seed, etc., that they also need. So that's really what we need to be doing. So our farmers, not just in the UK, but throughout the world, are faced with this increasing challenge to produce more food, but also more food sustainably. The first of the projects I want to highlight is Safi, and this is an acronym for Sustainable Arable Farming for an Improved Environment. This was a 5-year project costing £3.5 million, and this was instigated because there was a need for our arable farmers to actually address their farming practices, to look at their optimization of inputs, looking at their farm efficiency, but also to actually think about promoting biodiversity in their farming system. So this project looked at working with winter cereals. Now these are the crops which are most likely attributed to our declines in a lot of our farmland biodiversity, not just because of the habitat loss, but because of the intensive regime that is associated with our winter cereals. These crops are being drilled in the autumn, which means straight away we lose our overwintering stubbles, which are an invaluable resource for our farmland birds in terms of seed resources. So we wanted to address particularly winter wheat as one of those cereals. We also wanted to say what we could do at the edges of these fields. Could we make a space for wildlife? So here we have 2 situations. This is a picture of a winter wheat crop, and as you can see, it's a very dense crop. And this has really big implications, especially for our Skylight species, which is one of our flagship species. And so what we wanted to do with this, within this project was to actually look at what we could do within the field of that winter wheat for birds, in particular the Skylark. And so with the RSPB, we trialled these Skylark plots, these undrilled patches, which the farmer creates just by simply lifting up the seed drill, travelling over the land for about 4 metres, and then dropping the seed drill back in place. And so if you're ever on Google Earth, that's the kind of picture you will see. These sort of rectangular shapes in the field, those are those Skylark plots. This picture down here, this is a conventional system where a farmer would be trying to maximise returns from their land by drilling their crops right up to the hedgerow. This, of course, has implications for the wildlife in that hedgerow, but also we're not creating much space for wildlife in that system. Farmers over the years have been encouraged to actually take away their agricultural production away from that field boundary by creating these buffer strips. And that has been really successful. There's about 29,000 hectares of grass buffer strips in England alone. But we wanted to do more than that. When you just put down grass species, you're not providing a great variety of resources for a number of different species. So within the Safi project, we looked at putting in wildflower seeds into those mixes, and we investigated 3 different mixes in total, a grass one, and then 2 different types of wildflower mixes. So what about the skylarks? Well, in this project, the RSPB were responsible for the bird observations in the field, and so the skylark was one of those focus species. And one thing they found straight away was that the number of eggs being produced by our skylarks was actually greater when we had fields which had these skylark plots in. And this was deemed to be because there were more foraging opportunities for our skylarks in these areas because of these skylark plots. But of course, the eggs are only part of the story. What about the numbers of chicks being reared? And what was found here is that 50% more chicks were being reared where we had these skylark plots in place. And this was actually believed to be sufficient to actually reverse the decline of skylarks in the landscape if sufficient numbers of farmers took up this option. So what about our biodiversity in those buffer strips? Well, these are those 3 different mixes here, and the BTO were responsible for doing the surveys of the birds utilising these different seed mixes in those buffer strips. And what they found is, first of all, so these are the mean number of birds recorded per mix over the study. There's a lot of variation between years, but the take-home message here is that when you put in these wildflower resources, generally you get a better usage of birds, farmland birds, of these margins, because not only are you getting more invertebrate prey in those margins, you're also getting a greater seed resource as well. So a good benefit. What about our bumblebees then? Well, in this project, the CEH were involved with collecting data specifically on our bumblebees, and what we've got here is a plot of the bumblebee abundance per plot against the abundance of wildflowers in those buffer strips. And so down the bottom end here, we've got a low flower content, and so we've also got a low number of bumblebees associated with it. And basically, as you increase the number of flowers in your buffer strips, you also increase the number of bumblebees. That's not surprising. When you've got options like this, you've got these nectar-rich plants in that situation, which of course is going to be a valuable resource for those bumblebees. So, as this is a conference on sustainability, are these skylark plots sustainable? Are they sustainable for the farmer? Well, if you're in the agri-environment scheme, you'll be encouraged to use this option in your arable fields, and you'll be expected to put in 5 of these plots per hectare. So you're going to be taking out 80 metres squared, roughly, of your land from production. But in return, under the agri-environment scheme, you will get 5 points per plot, which is basically £1 for every point, which means you're going to gain £25 per hectare. So that's not bad for a farmer. But then, when you look at wheat prices, £215 a tonne on average. And so when you actually look on an average yield of, say, 8.5 tonnes per hectare, that can, of course, go up to 11, 12 tonnes on a very productive farm, then you could be losing around £15 per hectare on that farm by putting in these skylark plots. Well, actually, ADAS were looking at the yields, and they actually found that there was no significant difference in yields over the 2 years they studied between where you have a conventional system with no skylark plots compared to those where you have. So statistically, there's no yield differences, but actually for the farmer, they're still losing that £15 per hectare. But overall, there's a net benefit of £10 per hectare for putting in these skylark plots. But of course, this value doesn't take into account that it may take more time for the farmer to actually drill their crops, but it also doesn't take into account the fact that they're not having to put so much grain into that field as well. So these are really sort of ballpark figures. But ultimately, we have to ask the question, where is that incentive for that farmer for £10 per hectare? Where is that incentive? And so far, it's not been a very successful option in agri-environmental schemes. There's only about 580 farmers which have taken up this option out of about 43,000 agreements. So if we're to reverse the decline of skylarks, we're not going to get there with the limited uptake of this option. What about our buffer strips then? Well, under the agri-environmental scheme, you'll get £400 for every hectare of buffer strip you put down. So for a 1 kilometre strip, you're going to get £240. So not bad money. But then when you look at the yields that you're going to lose by taking that land out of production, at the headland you can expect yields to be about 10% less. So you'd say around about 7.5 tonnes per hectare. Straight away you're going to lose nearly £1,000 in wheat from putting in these buffer strips. On top of that, you've got the expense of the seed and also the establishment for putting in these margins. If you go for the very simple grass-only mix, which most farmers are, that would cost you about £75 just for that seed. But if you go for one of those floristic mixes, then it can cost up to about £800 for putting in just 1 kilometre of these buffer strips. So a farmer potentially could lose up to £1,500 for every kilometre of these buffer strips they put in. So where is the farmer incentive to do this? They're not getting the money back for doing this kind of option. Another project is Suzzgrass, and this is sustainable grazing. I haven't made these titles up just for today either. So this was a project looking at managing species-rich grasslands, those associated with lowlands neutral pastures. And the idea here was to actually investigate 3 different management techniques that we could use so that we could actually manage these pastures for biodiversity, but also for the farmer in terms of animal performance. And so one of them was a static graze treatment, a continuous grazing treatment, where they were grazed from April to October under a moderate grazing pressure, so that we maintain a good sward height, which would then have biodiversity benefits as well. We then had a static hay treatment, which is basically your traditional hay meadow management regime, and then we had this dynamic treatment where the pastures were shut up for hay for 2 years, and then we had 3 years of your static grazing, continuous grazing, as with that treatment there. So that is what one of these hay meadows looked like, and this was down in Somerset. And then this is what a pasture looks like, which is being continually grazed, but under moderate grazing pressure. So you can still see flowers there. It's not being nibbled right down to the soil surface. Lots of different data was collected from these sites, from the botanical composition to animal performance, which of course is really key to that farmer. So, as I started off with saying, we need to get our floristic diversity right. We need to improve that if we can. And what was found with this study, that under all of those treatments, we were increasing the percentage cover of our positive indicator species of wildflowers that we want to encourage in those systems. But what was also found is that we did this to a greater extent with the static hay and that dynamic treatment. So we're having benefits for our floristic values. I haven't got time to show you all the responses, but I thought I'd show you the butterfly responses. You can see that 2007 in this colour here, I'm not going to say it's red, it's meant to be red. 2007 was much better for butterflies than in 2008 and 2009. But the overall message here is that it's the static hay and that dynamic treatment which was providing more resources and therefore providing a better benefit for these butterflies in that situation. So what about the all-important animal performance? Well, if you're a conventional farmer and you've got a very species-poor grassland which you're putting lots of inputs into, you would expect your beef cattle to grow by about 700 to 800 grams per day. So against that, what were our cows doing? Well, we were gaining 0.67, so 670 grams per day under that continuous grazing. So one thing to bear in mind here is that these are different breeds to what you would expect under a conventional system. But what you do find in this system is that animals take longer to finish. That means basically to grow onto slaughter. And also, under these management regimes that we also had very low stocking densities. So you have to think, is that going to be sustainable for that farmer? Because the returns they're getting from their land is being compromised. What was really interesting, though, is that after the hay cut, you allow the foliage to grow back, and then you graze, to have aftermath grazing. And animals were putting on 1.14 kilos per day, so it's a really productive time for those livestock, and much better than what you would get from that conventional grassland. So it's just something to bear in mind there. The farmer, as part of the higher level stewardship scheme, was actually getting paid £200 per hectare for actually maintaining these species-rich grassland with these kind of regimes. But ultimately, where is the farmer incentive if they're not able to maximise the returns in terms of yield of beef being produced from their land? The last project I would like to mention is this one here, the Agricultural Greenhouse Gas Research Platform. This is a project which is still going on in collaboration with the University of Reading. And DEFRA are funding this £12.6 million in total across numerous different types of projects. Have a look, do a Google on that name, and you'll be able to find out more information about this whole research platform. But this platform is all about providing new evidence about changing farming practices. So looking at future crops, looking at different ways, different farming systems, and how this is actually affecting greenhouse gas emissions from those agricultural landscapes. The study that I'm involved with is that of methane emissions from dairy cattle. And so one really amazing fact here is that dairy cows produce up to 600 litres of methane a day. And so when you know that that is actually more potent than CO2 as a greenhouse gas, then actually that is quite worrying. But what is really interesting is that the production of methane from ruminant livestock is affected by forage type. So what we wanted to do here was actually investigate how differences in forage type could actually influence the methane production. And we used growing dairy heifers, so young dairy cows, which would later on go on to produce milk, and how their emissions changed were affected by different types of pasture. So we went with a conventional permanent pasture, which is mainly of ryegrass, which would have those high inputs of fertiliser, and we compared that to a red clover and ryegrass pasture, which is more typical of your sort of organic system. And then we had this enhanced pasture, where we took the conventional system and we got in some wildflowers into that pasture. So you're probably thinking, how do we measure the methane from those dairy cows, especially if they're producing 600 litres a day? These wouldn't be because they're young dairy stock. But basically about 95% comes out the front end. It's not coming out the other end. And we can measure that by basically putting in a tracer into the gut of the cows, sulfur hexafluoride, and that is actually released at a known rate, and then you can calibrate that against the amount of methane being produced. And so you can see here they've got these collars on, which is basically sniffing the air for that SF6, and then you can calibrate that with the methane. So now for the all-important results. Well, in terms of the intake, so we want the animals to actually be, consuming the forage that we're providing. It's clear that the cows were eating more forage on that conventional pasture. So we've got a significantly greater intake on the conventional pasture, which makes you sort of think, oh dear, is the enhanced pasture and red clover not going to be good? But actually, when you look at the live weight gain, which is LWG, we can see that the red clover pasture, the cows were growing quicker on that pasture, significantly more than with the enhanced pasture and the conventional pasture. But what for me is really important is that we've got no significant difference between our enhanced pasture of all those wildflowers in compared to what farmers are doing conventionally, those high input systems. Now for the all-important methane emissions. What we found here is that the cows which are on those enhanced pastures are producing significantly less methane than what is being found with the red clover and also the conventional pasture. It's about 28% less methane. It's a really good outcome for the project. And when you combine those methane production rates with that live weight gain, the two which come out the best are the enhanced pasture and the red clover pasture. So those are the sort of the key outputs. So are these enhanced pastures sustainable? Well, the environmental performance of the red clover pasture and also that enhanced pasture was much better than our conventional pasture. We got those reductions in methane emissions in relation to live weight gains, but also those pastures did not receive any fertiliser inputs during the 3-year study. They weren't measured for part of this project, but the biodiversity benefits are also likely to be greater where we've got those red clovers in and also those wildflowers. So another benefit. The important thing for the farmer is that the growth of the livestock was not compromised. So why shouldn't farmers do this? And actually, if they do it, and part of the higher level stewardship scheme, they can get paid £280 per hectare for actually doing that kind of management. So it's a really sort of win-win situation. So just to conclude, I've whistle-stopped through all of those projects, but it's evident that we are able to put biodiversity back into that farm landscape, but it's clear that not all of those options are sustainable in terms of sustainable for the farmer. Why should they do things at a loss? And so economic sustainability is a key part of that farming livelihood. So it's clear that these farmers do need realistic incentives for them to actually go about creating greater environmental benefits in the agricultural landscape. The Skylight one is a key issue there, that we know that this can deliver for the Skylarks, but the farmers aren't being incentivized to actually go ahead and put in all of those Skylight plots, which we can know make a difference. Some of you may be aware that there's the CAP reform which is going on, and they were meant to have made a decision with the new start in 2014. That's been put back until 2015 now, and the future of agri-environment schemes is open to change at the moment. And so what I'm hoping is that farmers will get fully compensated for what they're doing on their land, but also to take into account that some of these options are actually delivering more than just biodiversity. What about some of those other ecosystem services? What about carbon capture and storage? What about the pollination services that some of these wildflower strips will be providing for the adjacent crops, etc., by increasing the number of pollinators in those systems? So just to sort of acknowledge the Safi sponsors here. So we had industry involved from from Sainsbury's and of course DEFRA. This is one of those DEFRA linked schemes. And then the Susgrass and that methane project was funded by DEFRA. And I'd also like to thank colleagues from the RSPB, BTO, CEH for use of their data today to illustrate those points to you. Thank you very much.